Here are a few more U-substitution questions, and for these problems I'll be dealing with trig functions. So for the very first problem, I do have sine x being multiplied with cos x, and for your first step you need to figure out what will be your expression for u, and I will go ahead and pick u being sine x. And one of the ways where you can check whether you picked the right expression for your u variable is by just taking the derivative now. So what is the derivative of sine x? Well, the derivative of sine x is going to be cos x. Once you take your derivative, and if you see your derivative somewhere in the original problem, that's a good indicator that you picked the right expression for the u variable here. Okay, so after that, I will go ahead and update the original question now. So this is going to be u times cos x times dx. And then going back to my derivative expression right here, I can just move this around. I can take my dx and multiply that with the cos x. So now I have du equals to cos x times dx. And the good news, or the good part here, is that I see that the cos x here matches up with the cos x dx on the original problem, so now I can make a substitution step now. So integral sine u, and then I can multiply this by just du. Alright, so there you go, there's my substitution step. And then right now, one of the reasons why we use U-substitution is so that we can change the original problem into an expression where we can find the antiderivative easily. Now all you have to do now is there's a power 1 here, so we need to increase that by 1, so that will be u squared divided by the new power, which is 2 plus c. And then at the very end now, all you have to do is now substitute your u variable in. So sine x is your u. So this is going to be bracket sine x all squared divided by 2 plus c. And that's my final answer there. Okay, let's move on to the next question here. All right, so okay, for the next question, I have the integral of sine theta divided by the square root of cos theta. So I have sine theta on the top, and I have a cos theta on the denominator trapped inside that square root. So for my u substitution step here, I'm going to let u equal to cos theta. And I'm picking cos theta because cos theta looks to be in a more of a difficult situation because it's trapped inside the square root sign. And if I take the derivative with respect to d theta now, I do get negative sine theta. So the derivative of the derivative of cos theta is negative sine theta. And that's looking pretty good because once I take my derivative, do I see sine theta in the original problem? I do, so that's another indicator that I probably picked the right expression for my u variable. Okay, let's go back to the original problem now, and let's just rewrite this. I'm going to rewrite this as 1 over the square root of u, and then I'm going to times that by sine theta times d theta. Okay, and then what I can do next is I can take my derivative expression right here and I can just move that around. So the d theta right here, I can times that with sine theta. If I do that, I get sine theta times d theta. And then I can take this minus sign right here and multiply that with the du, so I get negative du. So I'm just interchanging the minus sign and the d theta. And now this is looking pretty good now because on my original problem I have sine theta d theta, and that matches up with this sine theta d theta over there. So now I can make a substitution step right away. So this is the integral of 1 over the square root of u times negative du. So there's my substitution step, and then I can take this minus sign and move it to the front. So now I need to rewrite this so that I can find the antiderivative a little bit easier, and that would be du there. And then I can take my middle term here, and I can write that as u to the power of negative 1/2. And this expression right here in the red box, I can definitely find the antiderivative of that. I just need to add a 1 to the power here. So my power is negative 1/2. I can add 1 to that, so 2 over 2. So that's going to be u to the power of 1/2 divided by the new power, which is 1/2, plus the c, and then the minus sign will just tag along. Okay, And after that, let's just simplify this a little bit more. I can take this 1/2 and multiply with that negative sign. If I multiply that together, I actually get -2 as my new coefficient times u to the power of 1/2 plus c. And ask yourself, what does u equal to again? Well, if I go back to the original problem, u equals to cos theta. All right, so let's go ahead and substitute that in now. So my final answer is going to be -2 bracket cos theta to the power of 1/2 plus c. And that's the same thing as -2 square root of cos theta plus c. All right, so that question wasn't too bad. Let's move on to the next one here. Question number 5. So for question number 5, I have this yellow expression multiplying onto that green expression, and you need to find the expression for u now, because this is a u substitution question here. Now, based on my opinion, I think the yellow part looks a little bit more difficult than the green part. So let's always pick the more difficult part first. So I have 1 plus sine theta for my u expression. And then I can rewrite the original integral as u to the power 2 times cos theta times d theta. Okay, and after that, I can take my derivative of my u expression right here. So let's go ahead and find the derivative. So it'll be du over d theta equals 2. Well, the derivative of 1 is going to be 0, and then the derivative of sine theta is going to be cos theta. So cos theta. And that's looking pretty good because I see my derivative over here. So all I have to do now is I need to take my theta here, my orange theta, and just multiply that up there. And then I have du equals to cos theta times d theta. Okay, and after that, this cos theta right here matches up with that cos theta over there. So now let's go ahead and make a substitution step here. So integral sine u squared times du. And once again, the goal of u substitution is for you to write the original problem in a way where you can find the antiderivative a lot easier. And the antiderivative of that is going to be u cubed divided by 3 plus c. Then ask yourself, what is the value of u? Well, the value of u was 1 plus sine theta. So let's go ahead and plug that back in there. So I get bracket 1 plus sine theta cubed divided by 3 plus c. And that's my final answer for that question. Okay, let's move on to a few more. Let's move on to question number 7 here. And I have a bunch of things going on over here, and I'm going to highlight these things right here. And I will go ahead and allow u to be equal to secant 2x, which is the power on the e variable, or on the e. So if I rewrite my original question here, I have the integral sign, and then e to the power of u times secant 2x times tan 2x, and then dx. Okay, after that, let's take our derivative now. What's the derivative of secant x? Well, I need to take the derivative, so that's going to be du over dx. And the derivative of secant 2x is going to be secant 2x times tan 2x. And then using the chain rule, you have to remember what's the derivative of this inside guy. Well, that's going to be just 2. So that's my derivative right there. And that's looking pretty good because I definitely see this on the left-hand side over here. So I probably picked the right expression for u there. And in order to kind of just clean this up here, or just to rearrange this, I can take this 2 here and that dx. These two things have to interchange. So that's going to be secant 2x times tan 2x times dx. And then the 2 is going to just go on the bottom on the du. So du over 2 equals to secant 2x tan 2x times dx. And now I can simply just make a substitution step here, right? So integral sign e to the u times, times du over 2. All right, that's looking pretty good. And then I can take this 2 here, move that to the front. So that's going to be 1/2. the integral sine of e to the u times du. And this expression right here, I can find the antiderivative pretty quickly because the antiderivative of e to the u is just e to the u plus c, and then I have the 1/2 in front. And the last thing you have to do is you have to ask yourself, what was u again? Well, u was secant 2x, right? So we need to plug that in over there. And I can finish this off by saying 1/2 times e to the secant 2x plus c. And there's my final answer for that particular problem. Okay, so we're making good progress here. Most of these questions aren't too bad. And let's take a look at this next one here, the integral of sine x over 1 plus cos squared x. And I have the yellow part and I have the green part. And ask yourself what appears to be harder or looks harder. It's probably going to be the cos x because it's being raised to the power 2. So let's let u be equal to cos x. Okay, and if I do that, let's go ahead and rewrite the original problem. So it's going to be sine x all over 1 plus u to the power 2 times dx. So that's what happens when you let u equals to cos x. And then let me just go ahead and just rewrite this one more time here. I'm going to write this as 1 over 1 plus u squared times sine x dx. And after that, let's go ahead and find the derivative based on what my u expression is here. So u equals to cos x, so the derivative of that, du over dx. The derivative of cos x is going to be negative sine x. And then from there, I can just interchange this minus sign and this dx, or this du, or sorry, the dx, sorry. So this is going to be negative du equals to sine x times dx. Okay, and that's looking pretty good again because over here, this sine x right here, it does match up with that sine x over there. So let's go ahead and find the, let's go ahead and do the substitution step now. So this is 1 plus u squared times negative du. And then on my next step, I can take this minus sign here and move that to the front. So almost done here. So negative integral sine 1 plus u squared times du. Let's go ahead and find the antiderivative of this guy right here. And if you go to your formula sheet, this is a special one. It's actually inverse tan. So inverse tan of u plus c, and then the minus sign just tags along. And then once again, you have to ask yourself what was u again? Well, u was cos x at the very top here in purple. U was cos x, so this u now changes into cos x. So my final answer will be negative tan inverse cos x plus c, and that's my final answer for that problem. Okay, let's keep on going here. Question number 9 now. Okay, let's take a look at question number 9 here. For question number 9, I have secant cubed theta times tan theta d theta. Now for this problem right here, I would go ahead and let's just work with this secant cubed theta here. That's the same thing as secant theta times secant theta times secant theta, and then you can times that by tan theta at the very end, and then d theta. One of the reasons why I'm going to rewrite it like that is because then I can show you that I can now combine, I can combine these two terms, and that's going to be bracket secant theta squared, and then I can times that by this remaining part right here, which is secant theta times tan theta d theta. Okay, so for my original problem, I'm just going to rewrite it like this. And then I'm going to let my u be equal to this secant theta here. So let's go ahead and just do that, and let's just see what happens here. So u equals to secant theta. And then if I do that, I now have the integral of u to the power 2 times, I'll put this in blue now, or sorry, black here, secant theta times tan theta times d theta. And then let's go back to my u expression right here, and let's take its derivative. So its derivative is going to be du over d theta equals 2. Now the derivative of secant theta is going to be secant theta tan theta. All right, so that's kind of a weird one. And then all you have to do now is just take your d theta, move it to the top there, and now you would get du equals to secant theta times tan theta times d theta. And that looks pretty good too, because this part right here matches up precisely with this expression on the left hand side there. So now you can make your substitution step there. So the integral sign of u squared times du. Alright, and that's great. U-substitution has done its job. It's turned the original problem into an expression where it can easily find the antiderivative now. So this is going to be u to the power 3 divided by 3 plus c. And remember, we know that u is equal to secant theta, so let's go ahead and plug that in. So this is going to be secant theta cubed over 3 plus c, and that's my final answer there. Okay, let's keep on going along. Question number 11 now. Okay, I'm going to highlight that part, and I'll highlight this part here. So I think usually like 80% of the time you want to let your u variable be equal to the expression that's trapped inside an expression here. So the green part is trapped inside the square root sign, so I will let u be equal to that. So 1 plus sine 2x. And if I do that, let me just kind of skip one step here. I'm going to rewrite this as the square as 1 over the square root of u times cos 2x times dx. So I'm just taking this part right here, and I'm just going to move that over there as one term there. Okay, and then let's go ahead and let's go back to our u expression here, and let's go ahead and take its derivative now, du over dx. Well, the derivative of 1 is 0, and the derivative of sine 2x is going to be cos 2x times 2. Okay, and after that, I'll take my dx and my 2, and I'll interchange those two pieces. So this is going to be du divided by 2 equals to cos 2x times dx. And that looks good too, because the cos 2x times dx, I can see that over here, and now I can now make a substitution step here. So the integral sign, 1 over the square root of u, and then I can now substitute du over 2 into here. So this will be du over 2. And then let's go ahead and rearrange this now. I can take this 2 and move it to the front. That's one of the integral properties, moving constants to the front. So that's going to be 1 over 2 times the integral of 1 over the square root of u times du. Okay, and what I'll do next is, instead of writing the middle term as 1 over the square root of du, let me just erase this now, and let me write that as u to the power of -1/2. Okay, so by doing that, now I can take the antiderivative of this expression pretty quickly by adding 1 to the power. So this is going to be u to the -1/2 plus 1, which is 2 over 2, and that's going to be 1/2, so I need to divide by 1/2 on the denominator, plus c, and then the 1/2 remains over here. Okay, and after doing some algebra here, the 1/2, they can just cancel off. And if I add -1/2 plus 2 over 2, that's going to be just positive 1/2. So u to the power of 1/2 plus c. And what was u equal to again? Well, u was equal to 1 plus, here it is, 1 plus sine 2x. And let's go ahead and substitute that in for this u. So this is going to be bracket 1 plus sine 2x to the power of 1/2 plus c. And if you want, you can write that as the square root of 1 plus sine 2x plus c. Okay, I think that does it for most of the trig questions. Let's just move on to some more u-substitution questions where we have e to the power of x now. So for this example over here, let me start off with highlighting the top and the bottom here. I will go ahead and let u be equal to the denominator here. And sometimes when you're thinking like, what should the u expression be, if you're not sure, just pick something. And then what you should do next is, once you've found your u expression, go ahead and take its derivative. What is this derivative here? Well, this derivative will be e to the x plus e to the power of -x times -1. All right, and if I go ahead and simplify this, this will be e to the x minus e to the negative x, and then du over dx. What you should do next is ask yourself, do you see this somewhere in the original problem? And the answer is yes. This actually lines up with the numerator. So that's how you can check really quickly if you picked the right u expression. Okay, so once I've done that, let me just kind of rearrange the original problem here as 1 over u times the numerator. So I'm going to save all this for the very end now. That's going to be e to the x minus e to the negative x, and I'll put that in a bracket, times the dx. Okay, so that's just me just transferring the numerator over to the side there. And one of the reasons I do that is because now I can make a substitution step by moving the dx over here. So over here, du would be bracket e to the x minus e to the negative x times, I'll put this in red here, a dx right there. And now you can see that this green part matches up with this green part exactly, and now I can make a substitution step. So this is the integral of 1 over u times du. And ask yourself, what is the antiderivative of 1 over u? Well, that is ln absolute value of u plus c. And then ask yourself, what does u equal to? Well, u was, at the very beginning of this problem, the denominator right there. So my final answer here would be ln absolute value of e to the x plus e to the negative x plus c. So that right there is my final answer for that problem. Okay, let's keep on going on with these questions here. Question number 3. Okay, for question number 3, a lot of things going on here. I have this part here in the brackets, then I have this part here on the power. So I will let the power be equal to my u variable, so 2x to the power of 3 minus x. All right, so how do I know if this power was the right u expression? Well, let's go ahead and take the derivative now. The derivative of this is going to be 6x minus 1. And clearly I can see that over here. Oh, sorry, 6x squared minus 1. So I can see that back in the original problem. So those are some pretty good indicators that I probably did the question correctly so far. Okay, let's continue on and let's figure this out. So if I rearrange the original problem, let's do that. One thing you can do right away is there's this 2 here, and we can move that to the front right away. So that's 2. And then I will take this part right here in blue. I will write that at the very front as e to the u. And then this part here in red, the parts in red, I'll just leave that at the very end now, or just to the side here. So yeah, doing U-Substitution, if you're still not comfortable with it, always take a few steps to rearrange the original problem so that you can clearly see the substitution steps here. And then over here on the right hand side, I'm going to take this dx and move it over there. So that would give me du equals to 6x squared minus 1. And then I'm going to put that in a bracket and then times it by dx. And then right away I can see that this green part matches up with that green part right there. So let's go ahead and now make the substitution step. Here's a 2 integral e to the u times du. And this part here in the red box, I can find the antiderivative of that pretty quickly because the antiderivative of e to the u is just e to the u plus c. And then this 2 can just tag along right there. And then what does u equal to again? Well, u is at the very top here, equals to 2x to the power of 3 minus x. So my final answer is 2e to the 2x cubed minus x plus c. That is my final answer for that question there. Okay, let's keep on moving along here. Number 5. Okay, so for number 5, what I'll do with number 5 is, just before I even find the value of u, let me just rewrite this as the inverse of tan x times, then I'll take all this part here in green and just write it on the side as 1 over x squared plus 1 dx. Let's just kind of split it up like that. And then I will allow u equals to the inverse of tan. Now the reason why I'm letting u be the inverse of tan is because I know that the derivative of inverse of tan is going to be 1 over x squared plus 1, which does match up with the green expression right there. Alright, so if I go ahead and just do a few little, just clean this up, this will be the integral of u times, and then let's go ahead and just take this dx and move it to the side here. So that's going to be du equals to 1 over x squared plus 1 dx. And then I see that this part right here matches up with that part right there. So it's going to be u times du. And then this part right here, we can definitely find the antiderivative. That's going to be u to the power 2 divided by 2 plus c. And then just substitute your u value here. Remember, u is inverse of tan. So my final answer is going to be bracket inverse of tan x squared divided by 2 plus c. Alright, so that's how you can do question number 5 there. Okay, I think I have one more question to go for this video homework guide, and then that'll be it for U-Substitution, a very long, video, and going over lots of interesting problems. Okay, for the next one here, because I've done this question in advance, we need to rewrite this as... So this part right here is the part that's going to cause a little bit of problems. You would write that as e to the x, and then that's being multiplied or raised to the power of 2, and then the dx is just hanging around. So that's one of the very first steps to this particular problem. You want to write it like that, because the next thing you're going to do is you're going to let u equal to e to the x. And the e to the x I'm referring to is the one on the denominator here. We're going to let that be equal to that. And if I do that, I'm going to now rewrite this as 1 over 1 plus u to the power of 2. And then this part right here in blue, I'm just going to move that to the side. E to the x times dx. Okay, and then from there, let's go ahead and take the derivative now. The derivative of u is du over dx, which is e to the x. And then I can take this dx here and move it to the side here. So this is going to be du equals to e to the x times dx. And that's looking pretty good because it matches up with that part right there. Let's go ahead and do a substitution step now. Integral sine 1 over 1 plus u to the power of 2 times du. And if I want to find the antiderivative of that, I can, because that's going to be the inverse of tan plus c. And then finally, just like all the previous problems, you just need to substitute u again. So this will be tan inverse of e to the x plus c. Okay, so thank you very much for grinding through that. That was quite a lengthy video there, but hopefully you understand the basic concepts for U-Substitution now.